So, stoichiometry. We've done a couple things to kind of get a feel for what's going on, but we're going to look at the actual numbers today. Keep in mind that the whole point of this is to find that quantitative connection between reactants and products. If you start with this much stuff, how much stuff do you make? I've handed you out a new sheet that I made this morning, which is why we're making a new video, because I'm teaching this slightly differently. So, this is the sheet that I'm referring to while I'm referring to a sheet. The back of it looks really busy with my handwriting. That's not for today at all. That's just an old thing I made several years ago that's got a bunch of reminders on it that you might find useful. We're only going to be looking at the side of the paper that does not have my handwriting on it, as it helps guide us through the process. So write this down. This reaction says that 4 nitrogen trihydrides react with 5 oxygens to produce 4 nitrogen monoxides and 6 waters. It's already translated, predicted, and balanced for you because you've already been tested on it, and I don't want to waste your time. I know you're good at that already, yeah? Take a look at that sheet that I handed you. If we were going to set up some stoichiometry here, I'd have to start to give you amounts of stuff. What are the maximum number of steps that you might have to go through to solve a stoichiometry problem? 3. All right? Do you see how in bold there's 3 different steps? What that sheet's going to do is guide you through how to accomplish the 3 steps. However, not all of the problems require all of the steps. What I want you to do is next to step 2, I want you to write the word always. Next to step 2, write the word always. You'll always do step 2. That part's required. The other 2 steps are connected to getting into moles and getting out of moles. Because of all the units that we'll use in stoichiometry, which is grams, moles, atoms, liters, moles is the one that connects the 2. All right? You've got to have moles to connect reactants to products because that's what the balanced ratio is. It's a mole ratio. So even though I don't know how many grams of this equals grams of that by just looking, I do know that it takes 5 moles of that to make 4 moles of that. And those 2 things are absolutely equal. So moles is key. It turns out that when I start giving you information in a moment, that anytime you see me write moles, I give you moles or I ask for moles, that's good news for you. Because that means that one of those other 2 steps that we only sometimes have to do are already done. So moles are your best friend today. So let's take a look at some given information for this problem. Write this down. I'm going to say that you've got 150 grams of this guy. And I want to know how many moles of him will form in the lab if that's how many grams you started with. Do you see any good news right away? Any good news in what I've written so far? Moles, right? The moment you see moles show up, it means you get to skip one of the 3 steps. Not step 2, because we'll always do step 2. But one of the steps is already done for us if moles shows up. So really your worst nightmare is when neither of them are moles, because that means you have to do all 3 steps. Now, before we get into the steps, first I want to let you know that that cheat sheet that you have It's a super crutch, all right? Dimensional analysis is the way you're supposed to solve these. And we've done dimensional analysis several times throughout the school year. So if you've already been good at that, then you're going to instantly be at least decent starting this. But this first problem will be rocky, all right? You will think that problem number 2 is much easier because you will have seen everything, so just bear with yourself. No matter what, my given value is going to go into the beginning of a grid. So I'm going to always just instantly put all of my given information into the start of a grid. 150 grams of oxygen, all right? 150 grams of oxygen. And then I can start getting that grid ready, like we're used to doing. Somebody read me the bold of step 1. What does step 1 say we generally need to do? It says the given has to be in moles. Is my given number in moles? No, so step 1's not the one we get to skip. We have to start with moles. This problem doesn't start us with moles, so let's turn it into moles. So just right across the top of the grid, I don't want grams of O2. I want moles of O2. That'll be step 1 right there. There it was. You can see the steps by looking across the top of the grid. Step 1, grams of the given compound. When I say given, I mean the one connected to the given number. Grams of the given compound is going to go to moles of the given compound. What does step 2 say we're going to then do? Just the bold part of step 2. It says mold of known compound to moles of unknown. We're then going to go to moles. Hey, what's the unknown compound here? Which compound is the question asking about? Right there, NO. The question is asking about NO. We're going to go to moles of NO. So there's step 2. Moles of the known to moles of the unknown. What does step 3 say we would then do?
Convert the moles of the unknown to whatever.
It says then we would convert the unknown to whatever the question wants to know. But remember, we're lucky here because what does the question want to know? It doesn't want to know anything else. So we get to stop right there. We get to skip step 3 because this step gives us moles of unknown. It's not asking for atoms or liters or something else. Cool. So we are halfway set up. So there's the steps. Now, if you remember, filling in the bottom squares was really easy because the trick was to make the diagonals match because that's what makes the units cancel out. So we just drug the information into the diagonal square, not numbers, just the letters. So I'm going to take the G of O2 and drag it down to this square. What will I write in that square down there? Yeah, just drag it. Moles of O2. So this would arguably be the hardest step in this, is just getting the grid set up. Now, the way you attack it from here is up to you. You have one of two choices. You can look at that paper that I gave you, and it gives you a wordy version. Or the better way to do it, in my opinion, is you can just use the information on that other whiteboard because all the numbers that go in all the squares except for the first one come from that whiteboard. I'm not giving you that paper on your test. I am giving you that whiteboard on your test. You don't have to memorize any of those numbers. That's the better way to go about it, but some of you like to read it. So if you look at your paper, what does it say to specifically do if you're given grams as your starting number? Look at step 1. What are you supposed to do if you're given grams?
Convert to moles by dividing the given number by the periodic table molar mass of the given compound.
It says divide by the molar mass of the given compound. Now remember, in dimensional analysis, this line right here is one big division bar. So it's saying that we want to divide that by the periodic table of that compound, which is the exact same thing that board tells you to do. What does it say goes with grams? Periodic table. What is the mass of O2? Anybody?
50.
No.
Wait, 32.8.
It's O2, not O. All right? So the molar mass of O2 is 2 oxygens, which is right under a mass of 32. Now, the step on your paper said to just divide that number by that number. So the only number I could put there that wouldn't mess with that division is a 1. And now, that times that is that number, right? Divided by that does what the paper says. Or, what number do we always put with moles? 1. All right? So again, there's 2 ways to tackle the same problem. That was step 1. This was step 2. Now, step 2 doesn't have options. Step 2 is always there and it's always the same. I'll read it for you. It says, multiply, we multiply across. Multiply by the coefficient of the unknown compound, and then divide by the coefficient of the given compound. You'll notice those compounds are already written in the squares. What's a coefficient? It is these dudes. In your grids, anytime mole is over mole, which will always happen because it's step 2, anytime mole is over mole, it's the coefficients. I didn't show my people at home that board. We're going on a field trip. Anyways, sorry. I was referring to that board and I didn't tell you, so now I feel bad. That's the board they copied at the beginning. Do you want to be on camera? You have to consent.
I consent.
That's Sophia! Anyways. Anytime mole is over mole, which will only happen during step 2, then it's the coefficients that automatically go in. Or, like the paper said, we're going to multiply by the coefficient of the unknown and divide.
President, do you have gauge flight?
No, I don't. School business.
Okay, thank you.
And divide by the coefficient of the known. Or it just matches the compounds that you already wrote in there. However you want to think about it. Anybody freaking out? We're done. Now you just got to solve it. Do you remember how to solve these? Multiply across the top, get a number. Multiply across the bottom, get a number. Divide the top number by the bottom number. Any brave soul want to share their answer with me? Just shout it out.
80.75.
Oh, it's too many sig figs.
3. 4.
That's not enough sig figs.
3.8.
I get 3.8. Look, there's only 2 sig figs in my given expression. That 0 is not significant. There's no decimal. So 2 sig figs in your answer. So what does this actually mean? I don't want you to get so lost in the numbers that you forget what you're doing. Let me ask you this. Do you think that 150 grams of oxygen is enough to make this reaction produce all the product it's supposed to?
Yes.
Let me rephrase for those of y'all that have no idea what I just asked. I know that when the reaction does what it's supposed to do, it's supposed to produce 4 moles of NO, right? That's what it's supposed to do. How many moles of NO was 150 grams able to produce?
3.8.
Not what it could produce. Which means if I sent you to the back of the room, you would ask me for more than 150 grams. Not much more. Look, it almost got there, right? But more than 150 grams of O2 could have reacted because 150 grams did not produce the full 4 moles that the reaction is capable of producing for one full click of the reaction. So keep in mind what we're doing here because, again, this process is being used across the city right now to make stuff that you buy. All right, let's do another one. Write this down. Four aluminums reacts with 3 oxygens to produce 2 aluminum oxides. What if I gave you 290 grams of heme and I wanted to know how many liters of heme could form? Do you see any good news in the way the problem is set up? It's terrible news, right? Because a problem that doesn't include moles is a problem that uses all 3 steps. The good news is that this is the hardest kind of problem that exists. Therefore, if you can comprehend what I'm about to show you, then you can do any stoichiometry problem. I don't have any twists to add into this like you sometimes accuse me of doing. No matter what, though, we always take the given information and put it into our first square. So we are automatically going to start with 290 grams of aluminum. All right. Step 1 requires that I start with moles. Do we have moles right now? No, so we can't skip step 1. So in step 1, we want to go from grams of known to moles of known. All right, because we have to start with it. So we want to go to moles of aluminum. So there's step 1. What does step 2 say to go to? From moles of known to moles of unknown. What's my unknown this time? Al2O3. All right, whatever the question is asking about. So you can track the steps. There was step 1's conversion. Here's step 2's conversion. Hey, on the last problem, we got to stop right there. But that was because it was asking us for moles. Is it David's fault? Oh, I said his name. David's famous too now. It's David Gallegos. See what I did there? Anyway. But it wants liters this time. So step 3 says, then convert to whatever units it wants you to convert to. So what should I write in that square? Liters of what? Al2O3. And now all 3 steps are being used, which makes this, again, the longest possible problem. Is it easy to fill in those bottom squares?
Yes.
It is, right? Just boom, 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 diagonal. They just match each other, all right? Not the number, so I'm just going to bring down grams of aluminum. I'm going to bring down moles of aluminum. I'm going to bring down moles of Al2O3. Again, on a computer day, when you call me over and you ask me why you're not getting the right answer, it's because you've made a mistake at this point. Oh, she called me. That's pretty cool. Hello?
Hi.
Hi, are you ready to walk down there?
Yeah.
All right, hey, it's cold out, right? It's cold.
I don't know.
Oh, it probably is. I mean, I can see sunlight, but dress warm so you're not the sick kid out there in a tank.
Okay.
All right. Hey, I'm teaching, so I'm going to keep going. You're going to be real careful, right?
Yeah.
All right. I love you.
Love you.
Anyway, as I was saying, usually this is where you've messed something up. All right? And that was my reminder to call her. So here we go. If you, I don't know if you're doing paper or board, whichever you like more, but the paper says that we need to divide that number by the pt mass of that compound. All right? The board over there says that the number for moles is always 1, and the number for grams is always periodic table. So for aluminum on the periodic table, we are going to end up with 26 point something, right? 26.98. Step 2 on your paper says multiply times the unknown coefficient and divide it by the known coefficient. Or the whiteboard says if moles is over moles, use the coefficients. The coefficient of Al2O3 is a 2. The coefficient of aluminum is a 4. Step 3 says, I want you to go look actually. Go look under step 3. And what does it say to do if the problem wants liters?
It says multiply the value you have after step 2 by 22.4.
By 22.4. All right? It just says multiply by 22.4. All right? Which means we would definitely want a 1 down there so that it didn't do anything extra to that step that he just read. Or the whiteboard says the conversion factor for mole is 1 and the conversion factor for liters is 22.4. We're going to be drawing our first card right here. So get an answer you believe in. How's it going, Sky?
Good.
Any neighbors out there?
No.
Oh, I heard you talk to somebody.
Oh yeah, for his birthday.
That's a neighbor.
Daddy,
What?
why are you whistling?
Oh, because my students are working a really hard problem right now. Do you think they'll get the right answer?
No.
Hey, do you want to, I'm going to need you to pick 2 numbers for me in a moment so you can pick who has to answer my question, but not quite yet. We won't make them nervous yet.
Okay.
Oh, yeah. Thank you.
Daddy,
Yep.
it's actually really cool outside.
Like beautiful?
Yeah, it's a really pretty day.
Yeah. Bummer you can't play outside today, right?
Why?
You tell me why.
What?
Why? You know why. Why can't you play outside today?
I don't know.
You're a liar. Sky, I want you to pick a number between 1 and 6.
4.
Now pick another number between 1 and 6. It's okay if it's the same number.
3.
You did good, baby. You did good. Hey, Mr. Lafferty, can you give me a final answer with good sig figs?
120.
He says 120. Do you like the way I wrote it? I wasn't talking to you. Do you like the way I wrote it? What's wrong with the way I wrote it? If you don't put that decimal at the end, you're wrong. Like the whole thing is wrong. All right? 3 sig figs because a decimal makes an ending 0 significant. All right? Therefore, we got to have 3 sig figs in our answer. And do you see the way that I'm circling it? All right? Because all you're doing is filling in the question mark. So my answer is 120 liters. And again, get your brain wrapped around what this is actually telling you. All right? And this one might surprise you. If I were to send you to the back of the room and give you 290 grams of aluminum with excess oxygen, all right? This assumes that you have as much of this as you want, all right? But if I gave you this much aluminum and said, do the reaction, the amount of liters, what does liters measure?
Liquids.
No. Volume, all right? It can measure gases also. That's a common misconception to think that it only measures liquids. It can measure, I mean, it's just space, right? Liters isn't good for solids, but you can measure the volume of a solid, how much space it takes up. The product that you would get would take up 120 liters of space. Do you know what a 3-liter bottle of this looks like? Right? So it would be 40 of those. And that's legit. Like, that's exactly what it would produce. So it's completely, you can apply all of this to let's go build some stuff. Let's do one more for today. Tomorrow is nothing new. It's just some of y'all benefit by watching me work out a bunch of problems and having it to look back on in your notes. But I don't have any twists for you. You just got to get good at doing this without being led. One more, write this down. Got a reaction with gold here. That's always kind of fun. So, I'm going to give you 0.68. What units do you want?
Moles.
Oh, look at that. You're getting smart. Moles of H2. And I want to know
Moles.
how many atoms of gold there are. All right, but realize if it was a moles to moles problem, you get to skip step 1 and step 3. And it's amazing. Like, it goes so quick you convince yourself you must have done something wrong. But that's no good for practice. Schoology will have you do some of those. But all right, y'all, we're still working together. You have Saren?
Yeah, the alarm is set.
Okay, is she happy?
Yeah,
All right. I love y'all.
love you.
Bye.
Bye.
The best video I've ever made. Okay. We're going to always put our given number directly into a group. All right, no matter what. So we're going to start with 0.68 moles of hydrogen. Now we can get going. Do we get to skip any steps?
Yes, the first step.
We get to skip step 1. I mean, it even specifically tells you below the bold. It says, if your units is moles, then skip this step. Or go to step 2 or whatever. All right? Because step 1 is to get your given in moles, and hooray, it's already there. So now we can go straight to step 2. Let's head on over to cluster 4, seat 5. Hey, 4-5, what letters should go directly into this square for my step 2? You went to step 3. So step 2 says that we can convert moles of my known to what? What does it say? To what unit of my unknown? Step 2. To moles, and you said gold, so you were good there. All right? But I'm going to ask you for the next step now, since you almost got yourself there. That was step 2, because we skipped step 1. All right? What does step 3 say that we can do? So what should I write here? Atoms is the unit that it wants to know. And my unknown is AU. Good job. Let's go to cluster 5, seat 5. Aspen, where are you at? Hey, Aspen, what letters should I put in this square? And what letters should I put in this square? She drugged the diagonals. Any questions? Let's go to cluster